Okay, so I'm going to go over the Chapter 10 problem set, question number 4. So to complete this question, you'll want to have your PowerPoint handy so that you can pull up the formulas. So let me find the formulas for pooled variance, because that's what the first question is about. So the question says, for the independent measures t-test, which of the following describes the pooled variance? And the first question is about the symbol. And so I can see here what the symbol is. So I'll just add that. And then I need to define it. So the purpose of pooled variance is to correct for any sort of bias that might occur when the sample sizes are uneven. So what you end up with is a weighted average of the two sample variances, weighted by sample size. The next question is about the standard error. So let me look back at the PowerPoint and find the question about standard error. So I could see here the symbol for standard error. It's very long in this chapter because it's the standard error of the difference between the means, and so it's M1 minus M2 as a subscript. And just like any standard error or standard deviation, it's the estimate of the standard or typical difference, distance between the difference in sample means and the difference in the corresponding population mean. Okay, so when I'm calculating the standard error, I typically first have to calculate pooled variance. And then in the t-test for the independent measures, the standard error is the denominator. So that was all the easy part. Now I need to calculate some things. So first of all, remember that the degrees of freedom for each sample is just n minus 1. So if I have 41 here, the degrees of freedom would be n minus 1. So it's 40 and 20. And now I have to calculate two things that I'm missing. So I'm missing a sums of squares, and I'm missing a standard deviation. So remember that to calculate the standard deviation, you need the square root of the sums of squares divided by n minus 1, or degrees of freedom. So to calculate my missing standard deviation, I'll start with that one. I'm going to start with the sums of squares, which is 924.8, and I'm going to divide that by my degrees of freedom, which is 20. And then I need the square root. So I just did this formula for the standard deviation, and the answer is 6.8. Now, the next question requires me to do the opposite, right? So I already have the standard deviation, and I need to get the sums of squares, so I need to do the opposite of what I just did here. So to calculate that, I would take the standard deviation and square it and multiply it by degrees of freedom. So you basically do the opposite of everything here. So I'm going to take 8.2, square it, and multiply by degrees of freedom. And I got 2,689.6. And now I can calculate the pooled variance. So the pooled variance is, this is when I need to refer back to the PowerPoint so I can see the formulas. So it's the two sums of squares divided by the 2 degrees of freedom. So sums of squares 1 plus sums of squares 2 divided by degrees of freedom 1 plus degrees of freedom 2. So I'm going to start with my sums of squares. I already have one here, so I'm just going to add the next one. 9, 24.8. And I'm going to divide that by my 2 degrees of freedom added together. 40 plus 20 equals 60. So I'm just going to divide that by 60. And I got 60.24. And there it is. So now I need to calculate the estimated standard error. Let me go back to the PowerPoint. And I see that the, wait a minute. Oh, I see that the formula is the square root of the pooled variance for the first sample divided by the sample size plus the pooled variance divided by the sample size for the second one. Let me write it down. So I have the square root of all this. So it's the pooled variance divided by n1 plus the pooled variance divided by n2. The reason we use pooled variance is when we have uneven sample sizes, which is what I have here. So I have my pooled variance at 60.24, and I have my two n's. So let me start plugging all this in. So it's 60.24 divided by 40 plus 60.24 divided by 20. And then it's the square root of the answer. All right, so 60 divided by 40. And I'm going to save this number. And then I'm going to do 60.24 divided by 20. And I get that number. I'm going to add the number I just saved. So I got 4.518, and then I need the square root. So I got 2.125. Wait a minute, I did something wrong. Oh, I think I know what I did. I divided by degrees of freedom instead of n. I wrote it down right up here in the formula, but I wrote the numbers wrong. Okay, well, let me redo this. 60.24 divided by 41 gives me this number. And 60.24 divided by 21 gives me this number, plus what I got a minute ago. Now I get this, and I get the square root. So it's 2.08. Okay. So don't make the mistake I did. When you write down the formulas, make sure you're pulling the right numbers. I wrote down n, but I didn't divide by n. Okay, so now I have to calculate the t-test, which is my mean difference. So it's m1 minus m2 divided by my standard error. So I'm going to do 14.3 minus 13.6 and divide the answer by the standard error that I calculated a second ago. And I got 0.336, so that would round to 0.34. And the total degrees of freedom for the t-statistic, I have to add both degrees of freedom together to give me the total degrees of freedom. So 40 plus 20 is 60. All right, let's see if I got them all right. And I did.